All right. Today we're going to start lesson 3 in energy. We've talked a little bit about thermal energy and heat. This lesson really is going to focus on it. It's a big hit for 7th grade. So we're going to take this lesson and divide it up into 2 parts. So we're going to do the first part today. And just like I've done in the past, I'm going to kind of go through and pick out the important things that we need to know. So our essential question is, what is the relationship between heat and temperature? We use those words interchangeably, and they're not. And by the end of the lesson, we should be able to understand the relationship between heat, temperature, and thermal energy. What I wanted to point out in this page over here is we're adding some new vocabulary to our Unit 8 on energy. So when you guys are doing Quizlet, you guys can add these words: thermal energy, heat, calorie, conduction, conductor, insulator, convection, and radiation. And these are some multiple meaning words. Like over here, it talks about, 2 definitions of the word conductor. You got the school's band is very good because the conductor is a great teacher, and that a metal spoon is a good conductor, so it will get hot if you put it in boiling soup. 2 different kinds of conductor. Make sure when you are doing your Quizlet cards, you are using the 7th grade science definitions for those words. All right, so let's talk about what thermal energy is. I'm going to change my page view here to one page so that we can get closer. So, what is thermal energy? Thermal energy is the total kinetic energy of all the particles in a substance. So we know that kinetic energy is moving energy, and we know that all matter has particles in it that are in motion. Even solids have, motion to their particles. So thermal energy is the total amount of energy of all the particles in that substance. In the SI system, thermal energy is measured in joules. Remember that temperature is not energy, but it does give a measure of the average kinetic energy of all the particles in a substance. If you have 2 identical glasses of water and one is at a higher temperature than the other, the particles in the hotter water will have a higher average kinetic energy. The water with the higher temperature will have a higher amount of thermal energy. So remember that thermal energy is the total amount of energy, of moving energy of all the particles in a substance. All right, it's not temperature. Now, temperature is measured, like it says. Temperature measures that total amount of kinetic energy, but the temperature itself is not energy. So let's talk about the difference between thermal energy and temperature. This big idea here. Temperature and thermal energy are different from each other. Temperature is related to the average kinetic energy of the particles, while thermal energy is the total amount of kinetic energy all of the particles have. A glass of water can have the same temperature as Lake Superior, but the lake has much more thermal energy because the lake contains many more water molecules. So let's think about that one more time. Temperature is the average of all the energy. Thermal energy is if you added up all of the energy in the substance. So a glass of water and the Lake Superior can have the same temperature, but Lake Superior is going to have more thermal energy because there's more mass to it. There's more particles. After you put ice cubes into a pitcher of lemonade, energy is transferred from the warmer lemonade to the colder ice. The lemonade's thermal energy decreases and the ice's thermal energy increases. Because the particles in the lemonade have transferred some of their energy to the particles in the ice, the average kinetic energy of the particles in the lemonade decreases. Thus, the temperature of the lemonade decreases. All right, so let's answer number 5. What are the 2 factors that determine the thermal energy of a substance? So go back up here. What are the factors? What do you need to know about a substance to figure out its thermal energy? All right. So let's zoom out a little bit. Look here. Whoops, too much. Let's do this. So there are fewer water molecules in the glass than in the lake. So the lake is going to have much more thermal. They could be the same temperature, right? So their temperature could be the same, but the lake is going to have a whole lot more thermal energy because there's more particles in it. There's more, we're talking about the total instead of the average. So the average temperature could be the same, but this one's going to have more thermal energy because it has more particles, more motion. All right, let's go ahead and do this next part here. At the bottom. All right, zoom in a little bit for you. So for each object pair in the table below, circle the object that has more thermal energy. Assume that they're at the same temperature. So their average is the same, their temperature is the same, so which one would have more thermal energy? Let's start with the first one. Would a bowl of soup or a pot of soup have more thermal energy? A small balloon and a large balloon. A tiger or a house cat, which would have more thermal energy? All right, guys, you should have chosen the larger object because the pot of soup, the large balloon, and the tiger, they are bigger. We're going to assume they have the same temperature. Since they're bigger, they're going to have more particles moving, more thermal energy. All right, so let's talk about what is heat. So we've talked about temperature, thermal energy. Let's talk about heat. You might think of the word heat as having to do with things that feel hot, but heat also has to do with things that feel cold. Heat causes objects to feel hot or cold, or to get hot or cold under the right conditions. You probably use the word heat every day to mean different things. However, in science, heat is the energy transferred from an object at a higher temperature to an object at a lower temperature. So heat has to do with the transfer of energy between something that's warm to something that's cooler, okay? When two objects at different temperatures come into contact, energy is always transferred from the object at the higher temperature to the object at the lower temperature. Energy in the form of heat always flows from hot to cold. So always goes from the hotter thing to the colder thing. For example, if you put an ice cube into a glass of water, energy is transferred from the warm water to the colder ice cube. So over here in this picture, the energy in the form of heat is flowing from the warm drinks to the cold ice. That's what causes the ice to melt. All right, so let's go ahead and do this section. It says for each object pair, draw an arrow in the direction in which energy in the form of heat would flow. So I'll give you some some choices here. For the first set, which direction would the heat flow from a metal rod to a fire? So if you're playing like a metal rod into a fire, which direction would the heat flow? From a hat to a snowman, which direction would the heat flow? And from an ice cube to a glass of warm water. All right, remember what we just said. Heat's always going to go from the object at the higher temperature to the object to the lower temperature. So it's going to go from the fire to the metal rod. It's going to go from the hat to the snowman. It's going to go from the warm water to the ice cube. All right, how is heat measured? Heat is measured in two ways. One way is the calorie. 1 calorie is equal to the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. Heat can also be measured in joules. Because heat is a form of energy, 1 calorie is equal to 4.1 joules. So that's all we really need to know about this. I'm not going to, you're not going to need to know the formula or anything like that. I just want you to understand that heat is measured in calories. So let's look here. This says energy in the form of heat flows from the hot fire to the marshmallow. It gets so hot that it catches fire. So how is heat related to thermal energy? Adding or removing heat from a substance will affect its temperature and its thermal energy. Heat, however, is not the same as thermal energy and temperature. These are properties of a substance, so used to describe a substance. Heat is the energy involved when properties change. So heat is that movement of energy. Think of what happens when two objects at different temperatures come into contact. Energy as heat flows from the object at the higher temperature to the object at the lower temperature. When both objects come to the same temperature, no more energy as heat flows. Just because the temperature of the two objects is the same does not mean that they have the same thermal energy. One object may be larger than the other and thus have more particles in motion. So, going back over here to this, eventually all of this ice is going to, the temperature of the ice is going to be the same as the temperature in the bottles. All that energy is going to be transferred and they're going to be the same temperature. But if we were to compare the amount of thermal energy between the whole bucket full of water and one of the glass bottles, the bucket of water is going to have more thermal energy because it has more particles in it compared to one bottle of soda. So that's what they were talking about there. All right. So looking at number 8, oh wait, did we miss number 7 somewhere? Hold on. Oh, energy in the form of heat flows from the warm mugs to the girls' cold hands. So the mug is warm, their hands are cold, so the energy is going from the mug to their hands. What is another heat exchange happening in this picture? So find another place where something warm may be transferring heat into something that could be cold. And then number 9, we're going to do, what will happen if two objects at different temperatures come into contact? Talked about it right here, and we kind of talked about it a little bit, what's going to eventually happen to this bucket full of sodas. So what will happen if two objects at different temperatures come into contact? What's eventually going to happen? Go ahead and answer that. All right, we're just going to do this last little half a page here. So let me change to just the page here. All right, so just to finish up kind of talking about thermal energy and heat, how can heat affect the state of an object? This is going to be a review. You guys learned about this last year. We even talked a little bit about it this year. The matter that makes up a frozen juice bar is the same whether the juice bar is frozen or has melted. The matter is just in a different form or state. Remember that kinetic theory of matter states that the particles that make up matter move around at different speeds. Remember, we talked about this. Solids kind of vibrate in place, liquids kind of flow over each other, and gases bounce all around. So their particles are always moving at different speeds. The state of the substance depends on the speed of its particles. Adding energy in the form of heat to a substance may result in a change of state. The added energy may cause bonds between particles to break. This is what allows the change of state. Adding energy in the form of heat to a chunk of glacier may cause the ice to melt into water. Removing energy in the form of heat from a substance may also result in a change of state. So if we remove energy in the form of heat, it may go back from a liquid to a solid. So you can see here, some of this ice is changing state. It's melting into water. So energy in the form of heat is being transferred and making that change states. So going back to what are 2 ways to change the state of a substance? So think about if we were going to change water. What are 2 things we could do to, what would you do to water to change it to ice? What would you do to water to change it to a gas? And the word energy should be in both in those answers. So go ahead and answer that. And then I think this is a good question here. I'm not going to have you make a list, but I want you to think about this and then answer it. So have you ever needed to touch a very hot object? What did you use to touch it without burning yourself? We're not going to worry about making a list, just think about it. And then did you ever need to protect yourself from being cold? What sort of things did you use? Now, thinking about those things that you used, what do the things have in common? So think about, what do those things have in common? So go ahead and tell me, go ahead and type an answer to that. All right. So we will finish this lesson up tomorrow. Um, so we're going to talk about the different kinds of thermal energy tomorrow.